Alrighty guys, this is page 19 of your interactive notebook about valence electrons and Lewis dot structures. In the Bohr atomic model, each energy level can only hold a certain number of electrons, and this is because electrons are all like charged, they're all negative, and so they will actively repel one another. We call this electron-electron repulsion. And so electrons will be further away from the nucleus when they're in higher energy levels, and each energy level has a certain number of electrons that it can hold. So on the left side of your notebook, we're going to list the first 4 energy levels and the maximum number of electrons that can go in each. Now we can have fewer electrons in each of these energy levels. These just represent the maximum numbers. Although before any electrons are put in higher energy levels, they will fill the lower ones first. So the first energy level can only hold 2 electrons. This is closest to the nucleus and it's the smallest energy level, which explains why it can only hold 2. Once we get a little further away from the nucleus and we have a larger energy level, the second one, we can put 8 electrons in it. The third energy level can hold 18 electrons, and the fourth energy level can hold 32. Electrons that are in the outermost energy level of an atom and that participate in chemical bonding are called valence electrons. And it's important to note here that these are not just the outermost energy level electrons, they're the outermost energy level electrons that also participate in chemical bonding. And this is going to be limited to a total number of 8 electrons. There's going to be a maximum of 8 valence electrons in each atom, and to determine the number of valence electrons, we just look at the group number. But this is only going to work for groups 1A, 2A, 3A, 4A, 5A, 6A, 7A, and 8A. These are the representative elements of the periodic table. The transition elements, which would be groups 3 through 12, are not going to follow this rule, but we're not going to worry about figuring out their numbers of valence electrons. So for elements in groups 1A through 8A, the number of valence electrons is going to be equal to the group number. So for example, an element in group 2A will have 2 valence electrons. So on the left side of your notebook, we're going to look at 4 examples and then figure out how many valence electrons are in each of these elements. So magnesium, when you find it on the periodic table, is in group 2A, so it will have 2 valence electrons. Chlorine, all the way on the right side of the periodic table, in group 7A, will have 7 valence electrons. Carbon will have 4 valence electrons because it's in group 4A, and oxygen will have 6 valence electrons because it's in group 6A. Now, as it turns out, because the valence electrons are used in chemical bonding, it's very important that we be able to not only determine the number of valence electrons in an atom, but also be able to illustrate them. And to do that, we're going to use a Lewis dot structure. A Lewis dot structure illustrates the number of valence electrons in an atom, and it will also illustrate the availability of those electrons to be used to form chemical bonds, but we'll talk more about that later. The electrons in a Lewis dot structure are represented as dots arranged around the element symbol. And of course, each element can have a maximum of 8 dots in its Lewis structure, since there's a maximum of 8 valence electrons that they can have. We're going to write these electrons individually on each of the 4 sides of the element symbol, with no more than 2 per side, and we're not going to pair any of them until there's at least 1 dot on each side of the element symbol. So on the left side of your notebook, let's look at 4 examples of Lewis dot structures. And we're going to use the 4 elements that we used above so that we don't have to redetermine the number of valence electrons. So magnesium, which had 2 valence electrons, is going to get 2 dots. And I'm always going to start at the top and work clockwise. So the first dot goes on the top, and we don't put the second dot next to it because we don't pair electrons until there's at least 1 on each side. So we're going to put the second one on the right side. Our second element, chlorine, has 7 valence electrons. So again, we're going to do these individually and not pair them up until we have to, right? So we're going to start here and do 1 valence electron. Then we'll put the second one in, the third one in, the fourth one in, and now that there's 1 on each side, we'll start pairing them. 5, 6, 7. So this will be the Lewis structure of chlorine with just 1 unpaired electron. Carbon has 4 valence electrons. So we're going to put them in the top, right, bottom, and left. You'll notice they're all unpaired. And then oxygen has 6 valence electrons, so just like we've been doing, we'll put one at the top, one on the right, bottom, left, and then we'll pair a second one at the top, a second one on the right. That's a total of 6, so we stop there. In class, we did a Lewis dot structure practice worksheet that looks like this. Go ahead and complete that worksheet and glue it into the left side of page 19, and you'll be finished with valence electrons and Lewis dot structures.